everyone. Thanks for coming on. We're just going to wait a minute or so for a few folks to come on. So let's just hold tight for a second. While we do that, I'm just going to bring up the presentation to get started here. Okay, I think we will kick things off. So good morning, evening or afternoon, everyone. Thanks so much for joining. Welcome all. We are here today to go through the Marine Technology Society member webinar. I'm Jarrah Orphan. I am an account executive on the spotter sales team here at Sofar Ocean. My background is ocean engineering. I have a PhD in marine technology and specializing in wave energy technology. So I'll be your moderator today for this session. And I'm excited to discuss real-time underwater acoustic monitoring with representatives from Bayquest here and Sofar. So before we dive in, I just want to kick things off with a bit of housekeeping, a brief overview of Zoom webinars. So attendees are in listen-only mode, and the webinar is being recorded. If you have any technical questions about Zoom, please just put them in the chat box. We'll sort those out. And if you have any questions for the presenters, kindly put them in the Q&A box, which you'll find down below it, at the bottom near the toolbar. There's a little conversation bubble icon with a question mark in the center. And you can do this anytime during the presentation. I will pose select questions to the panelists after the presentations today. Okay, so we're going to kick off with a brief introduction of Sofar Ocean and the spotter platform. And as you can see here, we are looking at a global map of systems. These yellow dots are spotters in the ocean. Before we get there, so Sofar was founded by an oceanographer, really based on the insight that collecting ocean data was just way too complex and expensive. So we're a San Francisco-based company. We build a full stack of hardware and software and applications to simplify ocean data and intelligence. Now, just keep those little dots in mind as we go through here. Our approach to building ocean intelligence is 3 layers. So we have the spotter platform. It's our hardware foundation for collecting ocean data at scale. There's thousands in the ocean deployed by us and our customers across science, industry, and government. And because Spotter is built for scale, Sofar ourselves has been able to scale up a very large network of free drifting spotters, about 600 in the ocean, relatively quickly. We have, and these were the yellow dots that you saw on the previous slide. So we have an internal team of oceanographers and meteorologists who simulate millions of data points from these spotters every day to create state-of-the-art marine weather forecasts. And that's just one example of the intelligence that these large networks can unlock. And at the top of the stack, we build applications that really turn raw, kind of arcane data into insights and decisions. A good example here is our Wayfinder application, which routes ships around the world much more efficiently based on big spotter data, accurate weather, and saves them a lot of fuel and, importantly, a lot of emissions. And what we're super excited about is actually we're seeing our customers deploy large networks of spotters as well, their own networks. And a good example here is in my home country, which is Australia. They recently deployed dozens of spotters around the entire coastline. And these are collecting unprecedented data at spatial and temporal scales to really understand the kind of complex coastal ocean dynamics that affect the coastline. This data is being used across many applications across science, blue economy industry, and public safety. So that's kind of where we are today, but it's important to kind of look at the context of ocean sensing and the status quo. So for decades, the approach has been to build big, exquisite systems that collect, scientific grade data, withstand the harsh ocean conditions. And this approach works. It collects critical data in remote locations, but it's very complex. It requires big vessels, a lot of special crew, these big systems, which makes it all very expensive. And these platforms are rigid, so they're built for one specific purpose, and you can't modify them without significant cost and engineering time. And this is mainly because, the insides, the brains of these systems kind of look like this bird's nest at the top here. A lot of complex systems trying to change things is just really difficult. So at Sofar, we kind of ask ourselves, like, what if it was easy? What if anyone can kind of collect data at scale without the cost and complexity that's normally associated with this kind of activity? And all of this is built and baked into the design of the Spotter platform, which is a turnkey all-in-one solution for collecting ocean data that makes it simple, affordable, and adaptable. So whereas previous technologies were complex, the Spotter is simple, you can deploy it in minutes from any vessel. It's connected in real time via cellular or satellite, and you get real-time data instantly in an intuitive dashboard to use. It's about 1/10 of the price for a traditional system, which means that you can get started really quickly, really easily. Or for the same kind of budget, get 5 or 10 spotters, deploy them at scale to really understand these kind of complex coastal ocean conditions and build up a good picture of what's going on in the ocean in real time. And what makes the Spotter platform truly unique is its modular architecture. So on the right there, you see the Spotter buoy. It's kind of interface between subsurface and the rest of the world. We have the smart mooring cable and an array of subsurface sensors, all of which connect together like building blocks into a system. And what this enables is you can easily add and swap in sensors over time as needs change. And the way that all of this is possible is through Bristlemouth. Bristlemouth is an open connectivity standard that powers the Spotter platform. You can think of it kind of like USB for ocean sensors, where it's easy to connect different things into a system without doing engineering work. So everything is plug and play, and over time, we're expanding the ecosystem of sensors that you can connect into the Spotter platform. And in the theme of simplifying ocean data, it's not just about collecting it, but it's looking at it and using that information. And so we do that with the Spotter dashboard, super intuitive, easy to use. We have a list of live Spotter data, as well as a map that shows your spotters, as well as a free drifting global network of Sofar spotters on a map. And then recently, we've actually pulled in the weather model that Sofar runs operationally as well. So you can really understand observations and forecasts in one place, and as well as historical time series data for analysis and real-time decision-making. Okay, so with all that, now to the fun part of the presentation. So our member webinar today is entitled How Real-Time Acoustic Monitoring is Transforming Marine Mammal Protection. So I'm excited to introduce our 3 speakers today. We have Ray Duran. He's the founder and executive director of Bayquest, a nonprofit based in San Francisco Bay Area, focused on wildlife conservation and education. He's a licensed 100-ton captain with experience in high-speed ferries, performance sailing vessels, and on local whale watching and eco tours. He's the former keelboat director for the Bay Area Association for Disabled Sailors, and heads up the program development and marketing communications for Bayquest. We also have Firuze Gotchi from Bayquest. She's a multidisciplinary artist, entrepreneur, and marine conservation advocate, blending sound, visual storytelling, and technology to raise awareness about ocean health. She's a project lead of the Bayquest Sea Sounds project, passive acoustic monitoring initiative studying the impact of vessel noise on humpback whales in the San Francisco Bay. With a background in marketing and non-profit engagement, Firuze brings a unique perspective that connects science, community, and innovation for marine conservation. We also have Dan Breyer here from Sofar. He serves the head of spotter product for Sofar Ocean, overseeing spotter platform, subsurface sensors, and assimilated data from over 600 actively deployed free drifting spotters. He holds degrees in mechanical engineering and material science, and has spent the last 8 years dedicated to using data to improve sustainability efforts. All right, welcome all. Let's start the webinar in earnest. Ray, please take it away. I'll stop sharing my screen here and Ray will share his.
Perfect. Thanks, Jared. I appreciate the introduction. Now let me go ahead and share my screen here with everybody. All right. 1 second, and there it is. Well, hi, everybody. It's great to be here with the Marine Technology Society. We really appreciate everything that you do to help us doing amazing things to help us look, learn, and listen and operate in our oceans. I'm Ray Duran. I'll be your co-host for this segment of the show.
And I'm Firuze Gotchi. Thanks to everyone for joining us. Today, we would like to tell you a little bit about our organization, share an exciting project that we are leading, then dive into how we are using spotter sound technology to conduct our wildlife research. Take it away, Ray. Can you tell a little bit about Bayquest, please?
I can, once I can get the slide to shoot on to the next one here. Okay. All right, about Bayquest, we are a nonprofit team of professional captains, marine science professionals, and conservationists working on the protection of aquatic life in and around San Francisco Bay. We bill ourselves as a maritime operation doing work in support of science and research. Most of us are licensed working captains out here in the Bay. Some of us are educators, ecologists, naturalists. We have some terrific acoustics and engineering support on the team, and some of us are highly accomplished digital artists like my colleague Firuze here. But what we all share in common is a profound respect for our local waterways and a deep connection to the wildlife within. Now, our work takes us in a couple of very different areas. Wildlife education programs takes us out onto some of the Bay's most historic sailing vessels to kind of share the wonders of Bay ecology with young people throughout the region. We're actively out in the field conducting certain type of things like acoustics sampling, rather, wildlife surveys, water sampling, and other things. And finally, we take every opportunity we can to actually get out into the community to help raise awareness of this wondrous ecosystem and the challenges it faces. We even on occasion get out and actually get our hands dirty, working with other organizations to do things like shoreside cleanup, invasive plant removal, and other coastal resilience type of projects. Bay ecology doesn't just end at the water's edge, but continues up the watershed and certainly up to the headlines. Now, my friend and colleague Firuze will share an exciting new initiative that we are heading up called the Sea Sounds Project. Firuze?
Thank you, Ray. And let me explain what is the Sea Sounds Project. It's a passive acoustic monitoring study. We use underwater hydrophones near shipping lanes in San Francisco Bay to record whale sounds and pair them with visual wildlife observations. The goal is simple: to understand how vessel noise affects humpback whales' vocalizations and behavior. This data helps us to understand how human activity changes the lives of the whales in our waters, and why this study is important. Whales depend on sound for survival. They navigate, feed, and communicate through it. But San Francisco Bay is crowded and very noisy. In 2025 alone, 24 whale deaths were reported, with at least 8 from vessel strikes. At the same time, climate change is altering whale habitats. Shifts in water temperature, salinity, and pH are changing food availability, and also the way sound travels underwater. By measuring these factors, we can better understand how noise propagates and how it affects whale behavior. In a time when federal protections and funding for marine mammals are being reconsidered, focusing on monitoring solutions is more urgent than ever.
Thanks, Fiducia. Now we're going to take you out into the field to show you a little bit about where this study is taking place. The graphic on the left, as you can see, is the actual nautical chart leading into the entrance into San Francisco Bay. We got the traffic separation scheme where bar pilots on board and disembark, vessels transiting into the area. The shipping lanes, of course, and here's the Golden Gate Strait and the Golden Gate Bridge. We're starting inshore and working our way out. Site D is located just outside of the Golden Gate Bridge. It's been the main focus of our early deployments so far. The photos on the right show the field as viewed from the vessel, and at about 1 mile wide and about 3 miles long, the Golden Gate Strait is a significant area to our study because of the heightened co-occurrence of vessels and wildlife in the area. Not only do whales transit in and out, but we welcome our harbor porpoise, bottlenose dolphins, and other wildlife that kind of congregate out in this area. Working out and up the coast, Site C is outside a marine protected area known as Duxbury Reef, very popular amongst the commercial and recreational fishing. B, of course, out by the northbound shipping lane, and ultimately with proper permits and permissions, we'd love to gently drop our hydrophone in at the southeast Farallon Islands, our version of the Galapagos, teeming with amazing wildlife out there. Now, Firuze, can you be kind enough to share what it is exactly that we're doing while we're out there?
Yeah, well, it's simple, right? We are collecting data, but what kind of data are composing the field observations? So on every mission, we collect 3 types of data. First, we record 30-minute underwater acoustic data of whales, vessels, and marine life. Then we synchronize that data with visual surface observations such as wildlife or vessel activities. And finally, we examine environmental readings, including temperature, salinity, and pH. Linking these data points helps us connect whale behavior with ocean conditions and vessel activity. Here you can see our field survey reports where we record our observations minute by minute to pair them with our acoustic data.
Thanks, Firuze. And if I can just add that all of this data, both the acoustic, visual, including these reports, will be available for public access. We're still working out the logistics on how to make that happen, but we want everyone and anyone from citizen scientists to researchers to policymakers to be able to jump into the folder and take a look and to listen to what we're doing. All right, let's take a look at spotter sound, the reason that we're here today. Here are a few photos to show what the system looks like both on board the vessel and what it takes basically to deploy it. This photograph on the left is from the first day that we took delivery of the system. We were very excited. by that, and we ensured the engineers that we would, be very careful with this very highly sensitive equipment. All the engineers in unison said, no, don't do that. We want to, we treat it as you would of any equipment on the boat. If it breaks, we want to know when and where the weak points are so that we can fix it. And we did. We didn't need to, but we did. We just say this is a very robust system. We deploy it each time that we go out, which means we're basically loading this whole thing up into our car, driving it across the bridge, loading it up on the boat, deploying, retrieving, and then doing the whole thing in reverse. And so far, it's been a very robust system, and it's held up to the challenge so far. And no pun intended with this so far. Now we'd like to take you on a very exciting boat ride with a short video recap of our very first deployment mission. Here it goes. All right, that was fun. We make a short video vignette of every one of our missions. So if you follow us on social, you'll see other ones as well. We're conducting our 10th mission tomorrow. Now here, we'd like to take you on the decks of the vessel and kind of show you how we deploy spotter sound kind of on a step-by-step basis, just so you can see how simple it truly is. The first thing we do is launch the spotter buoy, the head of the dragon, we call it, our favorite part, 5 meters of cable to our first sensor, which measures for temperature and barometric pressure that goes in. After that, we're paying out 10 meters of cable, different lengths of cable for each one of our study sites. Buoy right there for stability when it's under the water, and there's the Borealis hydrophone with a diver's weight attached to the bottom to help keep it stable while it's fighting the strong currents that happen there in the area. Then ultimately you can, launching the spot, still our favorite part of Fiduciate. And here's how it actually looks when it's deployed out there on the vessel. Now, just for fun, one Saturday, we loaded the whole kit and caboodle aboard my kayak and just pedaled outside the marina to get some samples. And as you can see, we managed to deploy and retrieve it without too much difficulty, even single-handed, although we did have a second chase boat for safety and just in case anything went wrong. And everything was going just fine until the afternoon winds kicked in and the ebb current began to draw us all out into the less protected waters of the South Bay area. But fortunately, with some vigorous pedaling, and through the windways, we managed to rescue the spotter before it got carried out onto the Great Pacific. And I think there we go.
So we also use deploy spotter sound system for marine science education. And spotter sound is always the star of the attraction for wildlife education tours. It's cool and gadgety, and it also helps us to introduce the science of acoustics to young people who all want to be more involved with marine conservation and technology as we move into the era of blue tech.
Okay, thanks, Fiduciate. Now, what are we getting while we're out there? Aside from the real-time dashboard analytics, which I think you'll see later in the webinar, we're getting some good quality acoustic samples from the Borealis hydrophone. And here's just a couple samples from our early deployments. Sound of an old fishing vessel that went through the study area, distinctive sound of those old diesels. Here's something a little bit more modern and surprise us a little bit. That's our new pilot boat. You can see jet propulsion creates a little bit different of a sound signature. And finally, here are some a random sound of whales that we're looking to capture during our study. We're trying to time our testing so that we get these whale sounds concurrently with the vessel sounds, basically to study any changes to the vocalization and the presence. So here's kind of what we're looking. Together. So as you can see, it gets pretty noisy under there. All right, off to you, Firuze.
Thank you. So let me talk a little bit about advantages of using spotter sound for this study. Well, during the planning phase of this project, we reviewed several equipment options we would need to deploy in this study. And we are delighted to have partnered with Sofar Ocean for the use of spotter sound technology. And let me tell you the benefits why we are enjoyed using it. Spotter sound technology is reliable, cost-effective, and easy to deploy with a minimum crew. It provides consistent, high-quality acoustic data, remote dashboard access, and consistent technical support. One of its most powerful features is the availability of real-time data. With AI-trained detection of whales, vessels, wildlife, it's an excellent tool for both real-time monitoring and also long-term research.
Thanks, Firuze.
Let us talk about the outcomes of this project, what we envision. Well, we do hope to accomplish with this important work is reducing entanglements and vessel strikes, creating public sound and visual library, supporting marine protected area management through voluntary slowdowns, fishing adjustments, and migration tracking. We also aim to train AI models to predict risks to whales. This project builds lasting conservation tools and gives scientists and researchers data to guide policy. Importantly, this work is a first step to creating an acoustic highway along the West Coast, like what has already been established on the East Coast. Our vision is to create a hydrophone network that could one day provide continuous acoustic monitoring to protect whales across their migration paths.
Perfect. Thank you, Firuze. And we'd like to acknowledge some of the very dedicated crew who've been on board the research vessel Mike Regal, as you see right here, for the Sea Sounds project. The amazing animal care team from Aquarium of the Bay, Pier 39 in San Francisco, are with us each mission to manage the vessel and ensure that we're operating safely and respectively around wildlife. Bayquest team members round out the crew. We've even welcomed aboard journalists from CBS News Bay Area, San Francisco's Mission Local, who've all taken an interest in our work and have shared it with the public. You can find those stories on their websites respectively. And finally, just acknowledging an absolute dream team that we have on this. Dimitri Ponarakis, our acoustics and sound master, senior noise analyst from Cornell University, has been our friend and acoustics advisor from the very beginning. He helps to ensure the data that we're collecting and the methodology are scientifically sound and follow proper protocols. Melissa and Kevin, director and associate director for animal care at the Aquarium of the Bay, amazing, on board with us virtually every mission. Kevin doesn't always wear his tux on the boat, but he should, because he looks really good. And our good friend Jim Trezzo, engineer and master tinkerer, with us on most missions to ensure that all the instruments are doing what they're supposed to do. Even brings along some of his home engineered gadgets on occasion to sample in the field.
Well, we also would like to give a big thanks to our amazing Blue Tech partners from Sofar Ocean, Applied Ocean Sciences, and Blue Oasis for their steady and consistent field support and encouragement. We are so delighted to be working with them on this project and appreciate all they do to advance new technologies to study and protect our oceans and the wildlife.
Perfect. All right, well, that about wraps it up for our segment of the show. Thanks again, everyone, for taking the time to join us today. If you want more information about our organization or if you have questions about the project, please feel free to visit our website at bayquest.org or drop me a line. Personally, my email is there. We welcome opportunities for collaboration, and as always, welcome donations and financial support to keep this study alive and going. We are a 501c3 corporation, and all donations to us are tax deductible. Thank you, Sofar crew. Now I'll go ahead and stop sharing my screen and turn it over to Dan, who will share more information about this very exciting new technology. Dan.
Thanks, Ray and Rute. Yeah, as Jara mentioned, Dan Breyer, head of product here at Sofar, and it's been amazing to partner with the Bayquest folks. I'm going to spend just a couple of minutes diving a little bit deeper into the technology itself and some other applications of how this can be used. So the spotter sound is part of this platform that Jar described of solutions that we are able to build off of this flexible modular kind of ecosystem. And the intent here is that we really believe strongly at Sofar around this distributed sensing, that to measure something impactful, you need scale, you need lots of data across a large swath of area, and you need to be able to mix and match what that is without needing engineers. And so here's a look at the full suite of what the platform can do. We're always adding new things, creating new partnerships, but everything we're going to talk about here for sound is equally applicable in all the other places that we have solutions. The way that the system works, and you saw some really great footage of these things being deployed and recovered, is we have at the top that base module, our spotter. This is collecting waves, wind, sea surface temperature, barometric pressure, all solar powered and self-contained. It's able to be moored or free drifting. For the Bayquest folks, they were basically free drifting these applications, but a lot of times for persistent data, these are dwelled using a mooring. They can be extended subsurface with the smart mooring to these subsurface payloads. Here we're using acoustics with hydrophones developed by AOS. And these hydrophones are really, really special. So while there are a lot of hydrophones that are out there, the reason why we chose these from AOS in particular, beyond the fact that they're bristle mouth native, so they are native to our protocol, they work as plug and play to our ecosystem, but they're incredibly low power. So we're talking about during operation, less than a watt of consumption. They have a great dynamic range. So 18 hertz all the way up to 25 kilohertz of range of omnidirectional listening capabilities. So you're able to get all the anthropogenic noise that you would expect, like we heard, but also a lot of the biological noises that you would expect and would be wanting to characterize. And it comes with the ability for onboard detection. So we believe heavily that data is only as good as what you can infer and process on the actual device, on the edge. And so inside each Borealis, a part of every spotter sound is the ability to load and host your own acoustic models. And I'll show some examples of that in a minute. But first, we've got this little video that shows a little bit more how the system looks, and just another look at how easy it is to basically deploy, recover, and move around. This is a system that we have persisted in a mooring configuration. So in addition to everything you saw, you also see a quiet chain to dampen any noise from the mooring itself and an anchor to keep it secured. And this allows you to basically collecting that real-time data for long periods of time, 6 months, a year. So I touched on this idea of onboard AI, and that's really what I think is the greatest differentiator when I think about the future of sensing, and especially distributed sensing. It's you'll never be able to send all the data that you want back to your kind of your home base. It's going to be too exorbitantly expensive, especially with things like satellite transmission costs. So the more that you can infer and you can do on the actual device is really where you're going to be able to have the largest amount of impact, whether it's for offshore construction, soundscape modeling, IUU detections, tracking and identifying whales. Being able to have an actual processor that can host and be updated remotely to send back detections rather than wave audio files is really the future that we see. And this comes in standard with every Borealis, every Spotr sound system has this native. So I'm going to jump into a demo really quickly, but as mentioned, all the data that does come off our system, whether it's from satellite or cellular transmission, gets telemetered into our dashboard. So you can actually have data that you can analyze and make decisions on without having to recover the system. Every ship, every travel, that time that we can save from you having to go out and recover is just operational costs and risk that we can mitigate for any of our end users. So this is a view of what that looks like. And we'll also talk about the data that we're getting from this, how we're storing it and making it public for everybody to basically use, because this is a wealth of information that we believe other people should have access to. So we'll pop on over. So what you're seeing on my screen right now is the device that we have that is right outside of our office over in San Francisco Bay, down in Ocean Beach. And it is sending us data every 30 minutes, telling us on the surface, it's just some straight conditions of waves, wave period, direction, wind, barometric pressure. But the real star of the show is it has it's a Spotr sound system. So it's also sending us verbose sound information with 15-minute sampling windows of both spectrogram across the entire broadband frequency, as well as sound pressure levels. So computed statistics from those ranges that we talked about. And this is really amazing because to be able to get this level of spectro allows you to slice and dice the information and drill into very specific things, like some of those whale calls or boat noises that Ray was describing. And once you're able to identify those things, you could then drill even deeper into the decade bands and try and understand whether something anomalous is actually occurring and if it's worth further investigating. All this data gets transmitted and scales automatically based on what type of telemetry that you have available. So if you are in a cellular range, we'll be able to send more data and send more verbose information. And then as you fall back into satellite or others, we will be able to scale that back. All the data that's collected here is also available to be processed and reviewed on your own using our API or as a download from the actual CSV, which you can do within the dashboard itself, or can be posted to any other application that you may be building. I also mentioned the sound library. So this is a growing collection that we host and manage, but are open to anyone that has any acoustic information that they want to share and make public to other people. This gives good examples of different things that our systems have heard and allows us to visualize and collaborate on the various things, both providing spectrograms, audio files, and any tagged information about what we've actually heard. So it's a great resource that continually grow if you want to get examples of mooring noise, high wind, precipitation, and see what it sounds like on a Spotr sound system. Right. I'll go back here. So I know I covered a lot of things. Definitely let us know if you have questions. We'll also be Oceans 2025 in, I guess, in September, so this month. So definitely if you're nearby or if you're visiting, stop by, ask questions. We'll have a lot of equipment there that you can also play around with and see. I'm also really, really excited. We are, as I mentioned, we're always expanding our ecosystem, always looking to see how we can increase our awareness and what the capabilities are. Later this year, we're going to be adding yet another sensor to this ecosystem. We're going to be adding a salinity sensor, which when you're talking about acoustics will dramatically improve our ability to understand and characterize things like acoustic velocity, and then give us better signal. Again, because it's part of our wrist-to-mouth protocol, it will mean we'll get the sensor fusion for free. All the customers will have to do will just be plug and play, and you'll be able to optimize based on these new sensors. So be on the lookout for those. If you're interested, please reach out to learn more. And we have a lot more coming up, including another webinar around coastal monitoring. We'll be happy to share those details as they get more firmed up. But that's it for me. And I'll turn it back over to Jara and get open up to some questions.
Awesome. Thank you all. Thanks, Dan. Thanks, Rizzy. Thanks, Ray. That was awesome. So we got a bit of time here for questions, about 20 minutes. So we'll be able to dig into some of these and yeah, help better understand the system. I suppose that there's a few that came in live and we can look at some of those. We also have a few questions that were posted earlier. And I maybe just start, there's a great comment at the start that someone made that is, you know, basically, so I'll just read it. So the idea is to replace a fewer numbers of complex data collecting systems that are complex and rigid with a large number of simple data collecting systems, which are spotters. So that really encapsulates exactly kind of what we're trying to do with the spotter platform. I have one that is probably relevant for Dan that came through, and there's a few questions kind of around spotters sounds real-time alerting. So one question for you, Dan, is can detections be QC'd in near real time by humans remotely?
Yeah, they absolutely can. So all the data that's coming off the system, you can set alerts and thresholds for any of those parameters we looked at. So for the individual spectra, so each sliver, and the computed statistics like sound pressure level, if there was a certain broadband or specific decade band that you cared about and a certain value, like you know that the hearing threshold for certain marine mammals is above or below a certain rate, you could absolutely get that, set up that alert and get that notification emailed to you that you've exceeded that threshold. And then because we're offloading the actual spectrogram itself, you can look at that and be able to determine whether or not you're getting any additional noise or need any filtering or byproduct filtering that you would require, like additional mooring noise or high currents. So you'd be able to see that in essentially for every update that you're getting. So as close as every 5 to 15 minutes, depending upon what you've configured. So you can do all that by hands, by human, by eyes. But where, again, I think where our system really can shine is once you've codified and figured out what those parameters are, you can build that into an easy application that can then be hosted on the spotter sound itself, and that can run natively on the device. So let the robots help with some of that you keep seeing.
Awesome. So I'll take one from the live. It's from Andrea. Nice to see you, Andrea. Thanks for joining. And the question is what is a quiet chain? And so this is something that Sofar has engineered and innovated. That, you know, if you deploy a hydrophone on a moorings usually have some metal components which can interfere with the sound. And so our engineers kind of built what we call a quiet chain, which is a system that kind of removes any metal connections from the mooring chain and metal components to really make the sort of self-noise of the system really quiet, minimize that so that the sounds from whales and vessels shine through in the audio recording. So perhaps another quick one for you, Dan, is what is the appetite for sending info via alerting systems for real-time notifications of whale presence in the area? You know, how is this data actionable to maybe take action for vessels in the area, for example?
Absolutely. I love this question. And that's exactly why we partnered with the Bayquest folks. Like, data on its own is informative, but really it's when it gets into the right hands and in front of the right people, then action can be taken and improvement can, progress can be made. So our system is set up to be able to push this data to wherever sources that they want. I mentioned the API in the same way that you can set up those alerts and those thresholds. If any of those are reached, you can also set the system to post that data to whatever endpoint or whatever consumer, whether it's kind of a local consortium or the Coast Guard or whomever you want to be consuming this outside of yourself. You're able to federate and share that data. Devices themselves can also be shared and can be accessed. So the same dashboard that you saw or that I pulled up, you can also share that entity with anyone else as well. And then where this gets really, really fascinating or really interesting is because everything is designed to be modular, and you're running the detections on the actual device itself, you don't need to make that round trip of, send the data, analyze it, and then push it forward. If a certain threshold or detection is met on the actual AI, it can then also decide, hey, I need to do X, Y, or Z, like increase the sample rate or trigger an alert to any local craft. So it's really we've built the system to be able to do all those things, and it's up to the user to figure or to configure it the way that they want to get the alerting and insight that they want.
Awesome. So a couple of questions for Ray and for Izzy. You ready? We've received a few questions around emulating and potentially expanding the Bayquest Sea Sounds initiative. So are there any ways for citizen scientists to help with acoustic monitoring or marine mammal protection?
Yeah, Fiducia, go ahead and take that. Absolutely, there are.
Okay, so absolutely, as Ray said, actually we need citizen scientists to really have a widespread impact for this sort of study and also reach out to wider areas. And one of the ways that they can help us is if they have photographs, they can just send those photographs to Happy Whale app or Whale Alert, so that they can record it in their database. And if we have a pairing sound sample in that region, then we can just pair those data points together. So that's an amazing thing. The other thing that they can do is they can be volunteers to participate in our education sales or help us analyze spectrograms, or even if they have citizen scientists and they have sort of recordings by any chance, they can also share it with us, because we're going to share all our data with the public, with the scientists and researchers. So it's going to be a community impact, actually. That's what we try to do. We create a community awareness.
Thanks, Fiducia. And I'll add to citizen scientists, particularly in the emerging acoustics. There's a lot of people with hydrophones dropping it in. So I think part of our vision for having this public access, and I think Sofar has a similar file where people can upload and share their data, is part of our public access. We'd like to create some room or platform where other, acoustic, citizen scientists can share what they're hearing and what they're seeing into our folder. And there are a couple great model and examples. Our good friends at Happy Whale have a, probably the best in the business as far as, citizen scientist participation in identifying whales, particularly humpbacks and such. Orcasounds.net, our good friends who have a terrific acoustic monitoring system up in Salish Sea and in the Puget Sounds, very active in citizen scientists. So we certainly can't do this all alone. And then as acoustic technology and usage becomes a little bit more sound in research circles, I think more citizens will be actually out there doing it, taking a listen in. We can see a lot. I think, as Dan said, we can see a lot of things on the surface, and we can whale watch and we can take photographs. But the sea has a story to tell if we take the time to listen. So we're listening, and if anyone else is out there listening, we'd definitely love to have you share some of that data with us as well. Let's see what we can see and hear what we can hear out there.
Awesome, thanks, Ray. And a quick follow-up is, what do you think it would take to scale Bayquest, the Bayquest project, to potentially other regions in America or even globally?
So we need a lot of things, actually. One of the things, and the most valuable one, is crafting partnerships like the partnership with Sofar. And I feel like our partnership will have a long way to go, because we would like to have a widespread acoustic highway on the West Coast, just as it's established in the East Coast. So we need this partnership more than ever. The second thing is funding. In a time where funding for nonprofits or research projects are curtailed, we need a lot of help and donations. And the other thing is innovation like Sofar is bringing to the table, because the more innovation, the more flexibility we have, the more exposure to sound and the impact of anthropogenic noise to the whales or any living habitat in the ocean, because not only whales, but there are lots of other ocean species are impacted by sound. So we just need to be collaborative, and also citizen scientists is also important for us to get into wider areas.
Cool. So there's just a couple of questions around whether this recording will be shared afterwards. It definitely will. So be sure you can look at it at a later time. One on kind of AI, and this may be for Dan. Is there an opportunity to use spotter sound data that's collected to train an LLM on whale language, and generally the concept of collecting a rich data set that can be used to, get AI models to better understand soundscapes?
Absolutely, and that's our hope. And I would encourage whomever is looking at doing that of not only ingesting that information, so looking at all the data that's being ingested from the acoustics, but what's unique about the spotter sound as opposed to other acoustics is we're collecting a lot of other information that is co-located with it. And so if you have a true LLM, I would ingest that as well and say, what was, when we heard these things, what were the waves and winds? What were the salinity? What was the time of day that this was occurring, to try and further the capabilities of that predictive model. And then gold star is if you can take that then model and shrink it down with some tiny ML and deploy it onto an actual system, then in real time you can be testing and validating and kind of containerizing your that model with actual data, right? Like you're constantly validating and training and updating it in the field. And so in short, yes, and definitely if you're interested, reach out and we can talk more.
Awesome. So another one kind of around AI is, what do you think is preventing researchers and engineers from switching to an AI classification and detection models versus kind of doing it by hand and maybe a system that can do it automatically?
Yeah, I can give my take, but I'd be curious for anyone else on the call to chime in. I think there's kind of two sets of challenges that are there. One is there's just not enough data. The ocean is massive and sound is really hard to obtain. And acoustics are excellent, but you need not just that, as we've talked about, right? Oftentimes you need even more in order to create enough data to train something, and especially if you're looking for new things, new vessels, new patterns. It's really hard. So I think there's like a data shortage. And then I think the encouraging part is that we are seeing a turn of more sharing of existing models and more power that's being put into more tooling that's available to make more complex models separate out the sound. That's the other, I think, like really complex part that is hard for model detection is, like Ray played, if it's just you're searching for one thing, it's really easy. You're like, hey, that's a whale. But when in reality, you have layers and layers of sound. And so being able to parse that out, is the other challenge that I do believe tooling around pattern recognition and detection is getting better. Those are the two limits, at least when I talk to researchers, they run into.
Thanks, Dan. If I can add, just jump in on that as well.
Yeah.
One of the things that makes the Sea Sounds project a little bit unique is, in addition to our 30-minute acoustic samples and data collection, we're also doing concurrent visual observations at the surface. So anything that we see on the surface that can affect what we're hearing beneath the surface helps us to see what we're hearing and hear what we're seeing. A vessel, of course, coming by, for the example of whales, while we're hearing what we're hearing, we can also see and calculate the number of blows and surface blows that we're seeing, deep dives, how often that happens and how frequent that happens. So we document the visuals to go along with the acoustics, and that helps the AI team kind of put the two pieces together and at least create a data set on, as Dan said, specific vessels. We have AI identifying, large container vessels. We have, high speed moving vessels, fishing vessels, as you can see, and certainly the different kinds of wildlife. So we'll keep listening, but when we see what we see, we document that and send that off to our AI teams to help train those models. So acoustics, like Dan said, is a huge ocean, but adding some visual confirmation while we're hearing kind of helps move that AI training process along a little bit further. That's what we're doing anyway.
Awesome. And here's kind of one off the cuff, maybe for Rizzy, with your background in kind of marketing and storytelling. What stories do you think that you could tell with this data that you're collecting?
Well, my art sourced from whale spectrograms. By looking at whale spectrograms and at the same time listening whale sounds, it gives me more inspiration and anything actually. My aim is, and Bayquest's aim is, to bring stories with data. When data becomes a communication channel where emotions can influence, where you can make people take action, that makes it a really great tool to communicate and to use. Because when you just go for only the science and scientific words or technical terms, people just lost interest. But when you just combine it with sort of an art where you also let them listen to what's the background story, what's that whale's story, for example. This whale has a story. Where we have more time, I will explain more, but it's just a combination of everything come together. And I never forget innovation, because all this thing is possible with innovation. And I think we need more from Sofar, and also we're expecting more innovation from other marine technology startups and initiatives. Thank you, Dan. Thank you, Jara, for this.
One day build create individual stories for individual whales and track their journey through time. That would be pretty awesome.
Thank you.
Perhaps a question for Dan here is the spot of sound is obviously being used in this application to monitor marine mammals, but what are some other potential applications of measuring sound with spot of sound?
Yeah. This system is designed to be really flexible for long dwell. So the applications that we are seeing a lot of people using this for is around things like monitoring and classifying marine protected areas, generating soundscapes before environmental assessments during offshore construction. So if you have dredging or monopiling, you want to make sure that you're not you're compliant to any of the standards or not harming the surrounding ecosystem. All the way through to like IUU type applications where you're trying to identify vessels or people that are doing things that they necessarily shouldn't be doing, and you don't have the same spatial coverage for things like tipping and queuing that you would have, or you wouldn't have the aerial assets. So it's really just another pair of eyes and ears for a lot of the stuff that people are wanting to do that they don't have the long dwell capacity to be able to do in some really sensitive areas. Those are some of the things that I've seen them done for. The one personally that I'm like most interested in and excited for is around like rain characterization. So and being able to tell things like mixing and ocean chemistry and climatology. So how those things are changing, which is something that I never would have imagined, but is a really cool application for acoustics.
Yeah, totally. And we have 1 minute here, so maybe squeeze in one more question, which is, does the spotter do classification and localization of detected targets as well? And if so, is it at the edge on the cloud? So I'm happy to give some answer here. It can do classification with an AI model that is on the edge, it's on the device. it can listen for events that it's been trained to detect and send those detections in real time. In terms of localization, this is a very challenging problem, and it is definitely something that we're thinking about and building technology to enable in the future, with potentially an array of spotted sound systems where you can not only get the signal, but the directionality of that as well. Okay, I think we're about at time here. So thank you everyone for joining. This has been fascinating. Awesome to partner with Bayquest, and I look forward to seeing the progress over time as we continue to support and see the data that you collect and the stories that you tell as well as part of that. So feel free to say thank you and goodbyes, and then we'll wrap it up.
I want to say thank you, and joining us today, and also allowing us to explain what we are doing. And we need you. We need to collaborate, and we need to learn from you. So we are always open to any suggestions, any collaboration, or anything that you are in mind. And thank you.
Thank you, MTS and Sofar for having this today and having us and for everybody joining us out there as well. Please reach out with questions or information. We love to chat. We love to share what we're doing, and we always welcome new ideas and fresh approaches. So thank you all.
Yeah, just to reiterate, thank you so much, MTS. We really appreciate your support these webinars, and I think that's a wrap. Thank you, everyone. Have a good day.